Okay, today is August 18, 2025, about the quantum information. First, if you measure with z-axis, then you can't get the info of I phase because there is X, Y, Z phase, and if you do with G phase, then G phase itself is I, which is phase, so you can't measure it. And another thing is you can write down with cosine theta and sine theta. In this case, phi will be phase, uh, G will be 0 and 1, and X will be and Y will be I and minus I. If you rotate by G-axis, wait a minute, why I can't measure I'm a bit confusing, but I will do it next time. And also, there is like single qubit operation and there's Pauli operation, X and Y operation. So if you do Pauli operation, it will change over G, and if you do X and Y, it will change over, it will rotate along the x-axis and y-axis. And there's the difference between mixed state and the what was it? Mixed state and the coherent state. Mixed state is kind of probability. So if you calculate it, then this is this 1 0 is the column vector and 0 1 is row vector. So if you calculate it, then there will be 2 by 2 matrix come out and it will be connected to the density matrix. So mixed state there will be 2 by 2 matrix come out, and there will be density matrix come out. And for coherency state, uh I don't know how does it call in English. Is it like overlapped state or something? Then what comes out is you can hmm, what comes out is overlapped state. Anyway, I will do it next time again. Yeah. This is how can we represent the overlapped state? Then for g-axis, what gives is alpha and beta, so which means probability. For x and y, if you use x and y's both, then you can get I phase. And because it's probability alpha square plus beta square equals to 1. And for mixed state, it's a bit different. Mixed state, then what it will get will be the density matrix, and also some uh, hardware thing. There's trapped ion quantum computing. The difference between classical computer and quantum computer is qubit versus stable many bits, and quantum gates versus NAND and OR gates. They can make universal gate with just both, and parallelism between two inputs and one output. And for quantum, when you really implement the quantum computer, there is three steps needed: quantum initialization, manipulation, and detection. For each step, each of the company can use different technology, and fab technology is really important. For in NV Center case, they use optical pumping and radiative RF wave in current, and optical photon is what they are using. And in lecture, one professor, what he told is he trapped the ions, how they did it. After they did how they manipulated with classical computer, they run the TTL controller, and after that, it goes to RF generator, and the flow is RF generator control the optical modulator, and they shoot the laser on the trapped ion things so they can control. And this is Qubit in this case, if it is 2, but if it's 3, then we will call it Qtrit or something. Then Qtrit will be represented by uh, by SO3 or something. A problem is it's not, it can be not meaningful. There is theoretical stuff. It is, the research is still going on, but uh, for practical stuff, even a qubit is difficult these days. Thank you.